In this video, I'm going to go over how to solve equations that might get a different answer than just one single, like x equals 5 or x equals negative 2.3. So these examples are from the 2.4 alternate worksheet, and on some of them you will just get one answer when you solve it, but on some of them you're going to get the set of all real numbers, or you could say infinite solutions, and on some you'll get no solution. It won't be possible to find a value of x or g or anything. So to do these problems, you still start out the same exact way as we did before, which is just trying to solve the equations. So on number 13, my first step is to do the distributive property, but there isn't any here. And the next step is to get the variables on both sides. So I would subtract x from both sides, and when I do that, subtract x from both sides, x minus x is 0. There's nothing left when I take x minus x. So I'm left with the 2, the plus 2, is equal to, and then again I have x minus x, that's 0. The x is gone. When the variable is gone, that's when you're going to get one of these other two types of answers. It says 2 equals 4, and then you say to yourself, well, is that true? No, it's not true. 2 is not equal to 4. So you will say no solution for something like this. No solution. And again, you get that when the variable cancels. When the variable cancels, you'll get an answer. My pen's not working. Like no solution. I'm just going to abbreviate it to no sol. Okay, so if your variable disappears, then you'll have one of these two different kinds of things. All right, so let's look at number 14. No distributive property, so I need to get the x on both sides. And I'll just add this 2x to both sides. Now this time, my x's are not going to be gone from both sides. It's gone on the left, negative 2x plus 2x is 0, but I'm still left with 8 equals, and then over here we've got 2x plus 2x, which is 4x. This one we can just solve normally because there's an x in it. The x is not gone. So we would subtract 4 from both sides. Like I said, my pen's not working, so I'm using the mouse here, which is not very good, but 4 will be equal to 4x, and then you would divide both sides by 4, and you get an answer. You get x equals 1. So this is just a nice normal problem. There's nothing weird on this one. Number 15, we have 5 plus 3g equals 3g plus 5. Well, look at both sides. One side has a 5 and a 3g. The other side has a 5 and a 3g. They're rearranged, but they're really the same thing. And if we start trying to solve this by getting the variables together, you will see that when we subtract 3g from both sides, we end up with 5. A positive 3g minus 3g is 0. No g's left. And on the other side, you have 3g minus 3g, which is 0, and you're left with the 5. 5 equals 5. That's a true statement. So when you get no variable left in a true statement, you say many solutions or infinitely many solutions. I'm just going to write many. So what you do is you solve it the same as you would normally, or you could, in number 15, I could look at that and say, wait, that's the same thing on both sides, which means that you're going to have many solutions. If you have the same thing on both sides, you're going to have infinitely many solutions. Number 16, I need to simplify the 5x minus 4x, and I would get 1x minus 1 equals x plus 7. Well, how could x minus 1 be the same thing as x plus 7? How could that be? It couldn't. So when we start solving this and we subtract 1x from both sides, the x's are gone on both sides, and we're going to get negative 1. That minus goes with the 1, and it becomes negative 1 equals 7. That's impossible. That's not true. So this one is going to be a no solution. And then in number 17, we have to do the distributive property first. So we would get 2f plus 6 plus 4f, and that's 6f plus 6 on the left. And on the right, look at it, it's 6 plus 6f. It's the same thing on both sides again. When you have the exact same thing on both sides, you're going to have infinitely many solutions. And then finally on number 18, let's see, we can simplify the 3x minus 2x is going to be 1x plus 7 will be equal to 4x plus 10. And this is not the same thing on both sides. When we start solving this one, this is just going to give us an answer. The x's are not going to be gone. We're not going to lose both the variables. We're just going to solve this one normally following all the steps from before. And it's okay to get a decimal or a fraction when you solve for a variable. That doesn't mean no solution. Now, in most of our problems, it does work out that we end up with nice numbers, but we don't have to. In this one, we're going to get something got messed up there. Minus 10, minus 10. Oh, I see, right here. Minus, divide by 3, and we get negative 1 equals x. So we got nice numbers for all of these problems on this worksheet, but that doesn't mean you always will. It's not no solution if you get a decimal. You can just figure it out on a calculator. So the only time it's no solution is if you get a false statement with no variable, like 2 does not equal 4. Or negative 1 is not equal to 7. The only time you'll get many solutions is if you lose the variable and you get a true statement like 5 equals 5. Or in this one, I think you would get, I didn't finish solving this one. In this one, you'd get 6 equals 6. And that's true, so you'd get many solutions. So I hope that helps. Thank you very much.